Okay, so this whole section is just on acceleration. So I'm just going to run through a couple of sample problems, and then it'll be up to you to take your time and go through the rest of the problems. You'll find that a lot of them are very, very similar. Okay, so I'm just going to run through the first sample problem. A car travels 160 meters in 5 seconds. What is the average speed? So this one shouldn't be too hard, I hope. The total distance traveled is 160 meters. The total time is 5 seconds, and the speed is unknown. So this is pretty straightforward. This is distance, speed, time. So just use your triangle. We're after the average speed, and that's going to be the distance divided by the time. Okay, that's 160 meters divided by 5 seconds. Please note that the unit is meters above the line and seconds below the line. So that means that the speed carries the unit that's here, which is going to be what's that? 32 meters per second, I think. Okay. I'll do the second one. A car accelerates from 5 meters per second to 25 meters per second in 10 seconds. What is the acceleration? So this is an application of the acceleration formula. The acceleration is known as the change in velocity or the change in speed divided by the change in time. So sometimes it's written like this, but you guys might be more familiar with it as in acceleration equals, let me erase this one, the final velocity minus the initial velocity. In other words, it's the difference in the two speeds or the two velocities divided by the change in time through which the object is accelerating. Okay, so what we need to do is make our list. Before I've written my equation, I've kind of got ahead of myself there a little bit. I've written my equation, but I should really have taken the time to make my list. So my velocity, my final velocity is 25 meters per second. You can see that there. It starts at a velocity of 5 meters per second. And the change in time through which it's accelerating is 10 seconds. And the only thing that's unknown is the acceleration. So I've got my formula now and I'm ready to plug in some numbers. So it's the v quantity, which is the final velocity, which is 25. So 25 meters per second minus the initial velocity, which is 5 meters per second, all divided by the change in time, which is 10 seconds. Okay, so that gives me an acceleration of, and let me just zoom out just a small little bit, come up here. The acceleration is 20 above the line, 25 take away 5 is 20, divided by 10, and that gives me an acceleration of 2 meters per second squared. Okay, 2 meters per second squared. I do think that it is worth having a look at graphing when it comes to doing some of these acceleration questions. So I would like you to be able to at least graph the questions as they come at you. So I'm just going to try that there now, okay? I'm just going to put up an axis. So I'm going to put my speed time graph here, and I'm going to make it a little bit bigger, especially on the time axis. Okay, so now I'll start to label my axis, and I know I've got speed on this axis, and that's measured in meters per second. And I've got time on this axis over here, and that's measured in seconds. Okay, just move my head out of the way. So the next thing to do is to have a look. I know I'm going to have a change in time of 10 seconds. So I'm going to label this here as 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 seconds. Okay, from start to finish. I know I'm going to go to a speed of 25 meters per second. So I think what I'll do is I'll, on the y-axis or the vertical axis, I'll go up in fives. So I've got 5, 10, 15, 20, 25 meters per second on the y-axis. So let's just see what this looks like. The acceleration is, yeah, I've got everything right. So I've got 25 meters per second. The initial velocity is 5 meters per second. So if we focus on the description for a second, it says a car accelerates from 5 meters per second to 25 meters per second in 10 seconds. So that means that we should really be able to graph this pretty easily. We know that at the start, the car isn't starting from rest, it's starting from 5 meters per second. So I'm gonna, that's my initial speed at time equal to 0. 10 seconds later, however, it is doing 25 meters per second, and we're going to assume that it's doing it at a uniform or a linear acceleration, which is basically what our entire assumption is. So to graph that, I'm just going to graph it like this. Okay. And there we go. Easy peasy. Now, of course, you can also check at this stage, and you guys should be able to do that, that if you check the rise over the run, then that should also give you the same answer for the acceleration that we got in the calculation. So you just ask yourself, by how much has this thing risen? So the rise is a positive 20 meters per second. And it has run by 10 seconds. That's our run. Okay, so rise over the run sometimes is an easier way to do it. Okay, graphically it's an easier way to do it anyway. So the acceleration according to this would be the rise, which is 20 meters per second, divided by 10 seconds. That would give us 2 meters per second squared, which is the exact same thing. The last little thing that I'd like you to be able to do from this is to determine the distance traveled. Okay, so you've taken a word question based on acceleration. And now what I'd like you to be able to do is to figure out how far it went, okay, in that time frame. So I'm just going to erase those things that are in the way. Rise and run. And if you remember, the distance traveled is the total area between the line graph, there's my line, and the time axis. So if you notice, I've actually already split it up when I was doing the rise over the run. This is a rectangle here. This is area number 1. This is a rectangle. It's a long one. And this one here is area number 2, and this is a triangle. So the total area, or the total distance, is going to be the sum of these two areas, the total area underneath that line. So to work it out, you just follow your units, okay? Follow your units. So I'm going to work out area number 1 here, or distance 1, or really I should be calling it displacement, okay? Because it still shows the direction. So I know I've got a height of my rectangle of 5 meters per second. A bit weird referring to a height as being meters per second. But if you remember, one side of that rectangle has got a unit of speed. Okay. The time interval, the length of the rectangle is 10 seconds. So that means area number 1, or distance number 1, is 5 times 10, which is 50 meters, because our seconds cancel out. If I follow number 2 now, distance 2, well, distance 2, or area 2, this is a triangle. Okay, so again, I can use the rectangle method, which is basically the length times the width, or the height, whichever you want to call it. It's basically the same thing. But then, because it's a triangle, I have to remember that the area of the triangle is exactly half the area of the rectangle. So then I just divide it by 2. Okay, so it would be the length, the height times the length. So I'm just going to look at the length of this part of the triangle. So from here to here, bear in mind I've already done that first bit. That first bit we accounted for in the first sum. Second bit we'll account for here. So area number 2 has got a height of, well, between 25 and 5. So the difference there is 20 meters per second. Okay, that's the height of the rectangle, of the triangle. The base is the exact same as the base of the rectangle, which is 10 seconds. And then because it's a triangle, I have to make sure and split it in half. So area number 2, or distance number 2, is going to be 20 times 10 is 200. It's 200 divided by 2. What should happen is your units meet seconds below the line, seconds above the line, and you wind up with a distance of 100 meters there. So that means the total distance traveled is the sum of distance number 1, or area number 1, and distance number 2, or area number 2. So if you just add them up, you will get area number 1 is 50 meters, and area number 2 is 100 meters. So we've got a sum total of 150 meters. That is the distance traveled. Okay? So, just to reiterate, just to recap, okay, the slope of our acceleration, of our velocity time graph, our speed time graph, gives us the acceleration. You should be able to check the graph. You should be able to sketch the graph from the question. So what you should be able to do, here's the question over here, it includes the description. You should be able to sketch that graph, and you should be able to calculate the slope just from the rise over the run, having already done this part. Okay, just a quick sketch just to make sure everything is right. Okay, from there I would also like you to be able to calculate the distance traveled as well. Okay, so that's it. Please make sure you work your way through the rest of these questions. I'll do one more on one of these graphing ones in a little while, and I'll upload that as well. Okay, and don't forget, update your OneNote with your work. Thank you.